Hello and welcome back. Today we will talk about something extremely exciting. We'll talk about decision making. We'll talk about how AI can help us into this process of decision making and learning from our decisions. We'll talk about not only large language models, but also large market models. Uh, I'm sure you can't wait to hear more about what we'll talk about today. We'll talk about Fetcherr basically. And this company is represented here by Uri Yerushalmi. Yuri, how are you?
I'm great. Thank you for having me here, Pascal.
That's my pleasure, Yuri. And I know we already discussed a little bit about the topic, and you have a lot of great insights around decision making, and you have proven all your platform and the benefit that it can deliver with great companies. We will talk about that. But to start with, can you tell us more about you and about Fetcherr, the company you've started a few years ago?
Sure. I've been building various types of products, always relating to machine learning, AI, data science, even when it was not as common as now,
Mhm.
for more than 3 decades.
Okay.
I am a big believer of the technology that is behind the generative AI of now. Back then, it was called neural networks. Now it's more called deep learning. My PhD is in that field, in computational neuroscience, and after the PhD, I applied these type of techniques of decision making based on modeling on capital markets, algorithmic trading, high frequency trading. And about 6 years ago, me and my partners decided to take the same types of techniques and apply them on more traditional markets. And therefore, we founded Fetcherr, that is based on such types of technologies.
Excellent. So a deep basis foundation in neural networks. Even before ChatGPT came out and everybody talked about AI, you were there working and gaining experience from that. Can you now tell
Yes.
us about Fetcherr and what you're doing there? What's different? What you're bringing that is different?
Well, we believed in these technologies back then, as you said, just much before ChatGPT came out. So while most of the AI community was based on building models that are either generating text or generating vision, from our experience in capital markets, we understood that we need, in order to make decisions for enterprises, we need models that are based on market data, on
Mm.
business decisions. Therefore, while most of the community was focused on text and language and vision, we were based on building large market models. Therefore, it's not a large language model, it's not a large visual models. Now there are also talks about large world models that are being bases for robotics. In our
Mhm.
case, we have built large market models, and these large market models are the core technology behind in computational intensive simulations and optimizations that are optimizing. Actually, the potential is to optimize any decision making in any enterprise. Currently, we are more focused on the airline industry, and we have various products starting with making pricing decisions to inventory decisions to network management decisions. Everything is based on that type of deep technology.
That is very clear. Thank you. Thank you. So if I understand well, you started with trading, market trading. And I guess the reason why you started with that is because in this type of environment, you need extremely fast decision making and accurate as well because you're risking money, you know. So you've kind of built your experience on these, and now making this decision making engine available for other industries and especially airlines.
Yes, yes, exactly. So in both cases, we need a market model that is unlike language models that are based on text. We need a market model that is based on quantitative market data, because the decisions are basically quantitative. They are based on numbers. We need to make a decision that is not too high and neither too low. That's why we need quantitative data to be the basis of our predictions and decisions. And in these cases, the goal is not trying to imitate people, to imitate humans. Because language models, for example, are based on learning what did people write or say in the past, and now trying to imitate them. Here, that's not the goal. The goal is not to replace humans or imitate humans. The goal is to drive revenue, to go beyond the decision making of humans. And the capabilities here are capabilities that we will not see in textual data. The capabilities would be multidimensional. And there is a lot of things that are common among between trading and decision making in enterprises. In both cases, you need to optimize some decision and base it on predictions. You need to recognize some patterns that you see in the history and apply them into the future. You need to make decision based on vague status, vague data, probabilities, uncertainties, because you never know for sure what's going to happen in the future. You just have some predictions, some probabilistic distributions. And there are always factors that are apparent in any market. Always you have demand, you have supply, you have markets, your actions are impacting the markets. And these principles are principles that are quite common to what I've done before in algorithmic trading and here in more traditional markets too.
Excellent. So if I understand well, we've talked about large language models, which are basically built by bringing texts, all the text, I mean, large amount of text together, and at the end of the day, we have this algorithm that is capable of predicting text and basically talking with us and writing for us and whatever. And now you talk about those large market models that we could call maybe also large decision models, maybe because they are basically doing decisions. To build them, am I right to say that you've put together a large amount of decisions that have been made with their context and their details? Is it the way you've built it?
Actually, it's a little more complicated. We have a large market model that predicts what's going to be the future dynamics in the market. So the future dynamics in the market will be the prediction is dependent on your actions. So, for example, if I'm selling some product, let's say I'm trying to sell this phone, so I can predict how many people would buy that phone if my price would be 1,000. How many people would buy it if the price would be 1,001? So all of these predictions are trying to cover all scenarios, and the elasticity is predicted, the elasticity to the price, the elasticity to the competitive price. What would the competitor do if I'll change my prices? So that's the large market model, but that's not enough to have predictions. You need to take actions. So for the actions, there is a separate optimization phase that simulates the whole space of possible decision-making policies. So It's a very sophisticated pipeline that has in its core the large market model, but on top of that, it has also optimization processes that are simulating what's going to happen in the market given the decisions that I would be making.
Excellent. So if I understand well, it's not pure unsupervised learning as we see in large language models where we've put together millions of data and we got the magic out of it. It's more structured. You have some optimization that come into play. You have some supervised learning, if I understand well, and probably some unsupervised as well. But it's a more structured type of large model than the LLMs. Huh?
I'm not sure the right word is structured, but it's a more complicated because
Yes.
at the end of the day, I think the basic difference is not only that large language models are trained on text and large market models are trained on business data. It's also that there is here a need to be down to earth. At the end of the day, these systems need to seamlessly integrate into a business and make decisions that make money for the business, that drive revenue.
Yes.
So for that, you need to structure the solution to be seamlessly integratable into the business, to have zero risk onboarding, to have trust, because once there is no trust, people will just shut it off.
Yes.
So that's another basic difference here.
Excellent. And another difference, if I understand well, is that you not only create insights, basically those decisions, but also the actual execution of those decisions is part of the model, correct?
Exactly. Because once you have this capability to make smart decisions, and that capability is not done by humans, so the first advantage of it is that the decision is very accurate. But the second advantage is that you can make that decision endless times. You don't need to recruit millions of people to make million decisions now.
Yes.
You can just repeat the decision again and again, every millisecond, if needed, every microsecond, and to be much more granular. That's why in the space of decisions that are made, we can see now much more granularity. So, for example, in a pricing environment, you will have much more products than before, and every such product would have a different price because there is now some entity that can price every niche, every different type of product separately. And that's also a major revenue source for such enterprises.
I love it because this is, I mean, especially in fast consumer goods or even airlines, we'll talk about that, where you have a lot of products and a lot of small decisions to be made and currently are being made by humans and that are trying to be ahead of all this, but can't make those decisions well, and sometimes can't make them at all. And having those decisions being automated solves this big issue, and not only automated but optimized because you have a brain that is behind that, the large market model that is making them automatically. And I guess, and am I right to say that it also learns from the outcome of those decisions that it makes, so that it improves itself in time?
Of course. The system also, as any such, we can say it about reinforcement learning systems, there is always some space not only for exploitation of the information that we have about the information, there is always also some exploration. So we try things. The machine learning system tries things to see what is the impact on the market. So it always searches for the next best policy. And that's actually what makes it so sustainable, because it always improves itself based on the decisions that it makes.
Excellent. So I see the magic of it in so many that can apply in so many industries. But then I also think, okay, if this large market model makes decision for me and can even take action for me, how can I control this? How can I make sure that it's not making the wrong decisions and not getting to outcomes that are not desired?
Yeah, that's a great question. So as part of that policy of being able to seamlessly integrate it into the enterprises, these systems are designed to gradually gain confidence from the users, so that it's not that on the first day we just give it maximal degrees of freedom and just
Yes.
letting the AI do whatever it wants. The design is that the scale up is very gradual. So, for example, in airlines, we are giving it several routes to manage these routes. And we always start with giving it some guardrails or constraints. Never do these things, never do those things, never be above a certain price. So we always give it some space to play with. And we also, every decision is fully explainable. That's something usually you won't see in deep learning systems
Yes.
or in generative systems. Every decision is fully explainable. And it's quite difficult in our case because it's based both on the large market model and also on the optimization sessions. And the system is quite complicated. But even though the end user that wants to understand why did a certain decision was made, he gets full explainability and full vision into the factors that push the decision upwards or downwards, and also has the capability to ask the system, hey, I understand that you took this action, but I think you should have done that action. So if you would have done that action, what would have happened? And the system, based on the fact that it is very simulative, it can simulate what would have happened and explain to the user the consequence of events that are predicted based on these two theoretical decisions, and show why was decision A taken and not decision B.
Excellent. I love it. So it's not only helping you to make the right decision, making those decisions, acting on those decisions, but also helping you to improve your decision making by giving you feedback on what you've done as a decision, but also what you could have made as decision. That's
a great point, because
it's a coach. It's a coach. We are getting to a coach decision making.
One of the feedbacks that we get from clients is that it's not, for me as a customer that is using such a system, it's not only about generating the revenue uplift. You are also making me as a pricing analyst, for example, to be a much better pricing analyst, because now I see things that I couldn't have been seeing before.
Excellent. Yes. So we're talking about augmentation, augmented decision making.
Yeah, exactly.
Excellent.
Even though at the end of the road, many decisions are just automatic. So the case of having explainability and understanding what's behind every decision, that's good for having the right confidence, but eventually all users are giving some space for the AI. Okay, I trust you. In these cases, you have your freedom to do whatever you'd like.
Okay, got it. So so that's very important. If I understand well, you're working on the whole spectrum of business decisions in a company. You know, the what I mean here is you have strategic decisions in a company, like what should we do, what should be our roadmap for the next 2 years for marketing, for example. The more so those are more strategic. You have more tactical when it's what should be our policy or our to replenish our inventories, and you have the very day-to-day one, which is ordering, making the right orders and replenishing at the right time as fast as possible. Am I right, first of all, to distinguish those three kinds of decisions? And do you confirm that they are all taken into consideration in the platform? And are the users interacting differently with those three different type of decisions?
So, as for taking into account the different decisions, definitely, because I think it's the first time that there is a system that is not rule-based, it's goal-based. So,
Nice. Mm.
since we have this capability to make decisions based on simulations, we can, in every simulate, we can measure the outcome of in every simulation, we can measure the outcome of the simulation. So if the strategy, for example, of the airline is to sacrifice some part of its revenue in order to gain market share, the AI just gets that input that we as an airline want to gain here market share because we have this big strategy of the airline, and the system acts accordingly. So because it knows to choose the right policies that in the simulation generated the right outcome. So the system is goal-based. That's why it makes it very easy for such a system to get the goal and to tune itself to run to that goal. And it's very interesting that you divided the types of decisions into these three parts. So the strategic decisions are made by the enterprise, and they are translated then to what we call macro decisions and micro decisions. And the beauty here is that such a system, because of the nature of its simulations and large market model and technology, it can simulate both micro decisions and macro decisions and simulate them as a whole, meaning every decision is taking into account its counterpart decisions, why people didn't really think about that in previous structures. So, for example, the decision that is more, for example, crew or employment decision is that is pricing decision. These are two separate departments in enterprises that now are working as a whole, in a very holistic and integrated manner. And we've seen that also in airlines, where, for example, in airlines, there are pricing departments and revenue management departments. And because of the holistic attitude of the system, they are now seen as a whole, and all of the decisions are serving the strategy.
Got it. So it's a
Either
cascading,
micro.
It's cascading from top down and automating.
Exactly.
Excellent. Yeah, I mean, we've talked a lot about airlines. I would love to hear the projects you've worked on in this industry. I think you've implemented a lot of systems for them. Can you tell us about the use cases, and the outcome? I mean, the benefits those companies got from using it.
Yeah, so we have deployed such a system in various types of airlines, either different geographically or different size-wise, small and big, or different cost-wise, very low-cost airlines and very traditional airlines. And
I think we
because
can
this
say the
is,
name. It's the name are public. Huh?
yeah, some of the
Based
names
based
are
on my
public.
research, I found Delta, I found Virgin Atlantic. So all this is on the web. Huh?
Yeah, Virgin Atlantic, Delta, Azul,
Okay.
and more.
Mhm.
And what's interesting is that the system, because of its nature, that it is data related, it just learns from the data of the airline. So it doesn't, it's quite agnostic whether it's a large or small airline or low cost or not. And we are also approaching non-airline businesses because the nature of the system is data dependent and agnostic. And that agnosticity also allows us to make different types of decisions. So we start with pricing decisions and go to inventory types of decisions and also network types of decisions. And we have seen very interesting cases where, for example, we started back in the COVID days, and back then the whole market was in a big mess, as you probably remember.
Yes.
And the system looked at also World Health Organization data, and based on that, it made some of the decisions. So some of the decisions were, for example, taking into account whether there is a COVID wave in a certain place, in a certain origin, or in a certain destination. And these decisions are decisions that analysts are not used for. And that actually enables, it makes the analysts look at the decision and say, hey, there is something quite alienish in this type of decisions. Why did you, for example, we have some cases where the system senses, based on the features that it has, that there is a room to reduce price dramatically in some flight.
Yes.
And humans don't like that. Why should I reduce my price
Yes.
in 17%? But eventually we see that this decision of reducing the price gained the load factor, meaning it made the flight to be full, while all of the competitors had load factors close to 50% in that area. So in many cases, we see that even though some decisions are quite dramatic, at the end of the day, they gain very meaningful impact of revenue uplift.
Got it. And am I right to say that the system identified some disruptions before even people could see them and suggested some decisions to overcome those issues before even humans and identified them? So it's difficult for humans basically to understand, to reckon and trust the machine first, but then with time it's coming.
Yeah, with time, the confidence is coming, and the source of the ability to identify dynamics in the market that is beyond the capabilities of humans, it comes from different aspects. One aspect is this capability to cross-validate many small signals, and humans can't understand that these many signals because the system consolidates information about the market, about the competitors, about capital markets, oil prices, weather, events.
More than what our brains can do, definitely.
Yes. And so one aspect is that wide spectrum of signals that it looks at.
Yes.
And the other aspect is the granularity. So humans will not mess with one seat, for example, or one product that is sold only once, because there is no wisdom in
Yes.
applying
It's
any energy to that
it's
type of decision. But
yes.
here, the machine can apply this attention to this
Yes.
type of decision. And the other aspect is the speed. Many cases we see that, for example, a certain event occurred, and if the human would have known about the event occurring, then he would have reacted immediately. But it's also a capacity issue. The
Yeah.
machine immediately, at the second that the event has occurred, it updates the prices accordingly.
Excellent. So the reactivity, the completeness, and the insights that, yeah, and the predictions it gives on potential disruptions makes it a real augmentation to decision makers.
Exactly. Yeah.
Yeah, in terms of ROI and measurable outcomes, what have you seen? Is it like an uplift in revenue? Is it a decrease in costs? Is it a combination of both?
Yeah,
Is it
that's
easy? It might be difficult to measure it, by the way, because those are micro decisions that are combining together, consolidating together, and yeah, it's difficult in a
uh,
way to
yeah,
track it.
you are right. But as I said before, the principle of having confidence in the system is very important for us, especially where it's a new technology, and we need to have that kind of confidence and trust. So the whole system and integration of such system needs to be very clear, and the measurement of the goal needs to be scientific and clear and quickly measurable. That's why once the system, in our case, once the system is up and running, after a few weeks, 6 to 8 weeks, we can see measurable outcomes that are measured usually in revenue uplift
Okay.
based on scientific A/B testing. So we have a control group that we don't touch of
Ah,
products. We have our target group that is managed by us. We show statistically that they are very correlated one with the other before we take control. And after we take control, we see that before we to control, they are moving together. And at the
yeah.
time that we take control, there is a revenue uplift significant
Ah,
that that shows that the target group compared to the control group is has this significant revenue uplift. So the ROI is quite fast. Now,
excellent.
you also asked about costs. So I think the basic principle that we come with is that we are not here to save costs, right? We are here to make the revenue, and the revenue should have that's the combination of to make profit. So we have here the combination of the revenue
Got it.
and the cost.
Yeah.
So the decisions are adding to the end game of the revenue more than 10% revenue.
Okay.
And the cost is even bigger because many of the decisions are automatic. The humans are now much more devoted to the strategic types of decisions. So the time that is spent on micro decisions like pricing and inventory management and so is by 60% and more or less. So we gain the cost
Wow.
saving not as a target, but as an addition,
Got it.
but addition which is quite big.
Excellent. Excellent. Is it maybe also one of the outcome, the avoiding the mistakes in decisions? But this is very difficult to measure as well. But I guess it is. The
Yeah. There are type of mistakes that would no longer happen in such a system. In trading, we call this fat finger decisions, where your finger is fat, so you didn't click the right the right button. And yeah, humans tend to make a lot of decisions, but I think even the revenue uplift that we are seeing is a revenue uplift that does not take into account the decisions that are mistakenly done by humans on the control groups, because in the A/B testing, still it's an A/B testing, so the control group is controlled very well by humans. So
Yes.
it's the A team of the humans competes with the AI, and still the AI makes more than
Less
10%
mistakes.
revenue uplift.
Yeah, yeah, excellent. And so let's talk about the how now. If I'm watching our discussion now, I'm running a company. I mean, whatever the industry, I understand well. Whatever the industry, we can benefit from the system that you're describing. How can I get started? I mean, how can I use it?
Well, our system is now applied in mainly in airlines, and we
Okay.
are starting also to apply it in other verticals. I think enterprises that are looking to apply AI should not let themselves to be left behind. Meaning, we as enterprise managers should apply such systems no matter what. But the cautiousness is critical here, meaning choosing the right vendor, being able to differentiate between products that are based on the hype and products that are real AI decision
Yes.
makers. Always base yourself on measurable KPIs. These are things that we really believe in, and the measurement of the impact of such tools and decision makings is crucial.
Excellent. What are the critical success factors in implementing a large market model? What you have seen as the right way to do it?
Success factors, for example, you relate to
For
oh
example, yeah, should it be driven by management? Should we involve everyone in the company? Should we start with a small use case and then expand? Should we build a work team that starts working on identifying use cases and get to implement them? What is the most important thing that you've seen as successful in the companies?
I don't think that the enterprise is expected to understand all of the bits and bytes and how of the system. The enterprise should be innovative enough to start at a certain point. It should have the capability to take risks, but small risks. Start small and have this confidence in science, meaning once you see measurable outcomes of the small scale start that you have started, then give it more freedom.
Got it. Start small. Make sure you have measurable metrics to gauge the success of the implementation.
Start small, have measurable outcomes, and third point is, as you have measurable outcomes that are successful, then scale up. And you don't, as a business owner or as an enterprise, you don't need to understand how does the system work. You just need to put it the right guardrails and make sure that the outcome is positive.
Yes.
And to have confidence, to have enough guardrails and KPIs to have enough confidence in the system.
Excellent. I mean, what you've described from the beginning is just a dream for me because I really believe that there are very important decisions to be made in companies at the strategy level, but most of the small decisions on a day-to-day basis are just some things that humans can't cope with it. And I think it's getting harder and harder because the environment is moving faster and faster. We have more and more information. So we need the help of technology to help us make those decisions. And I really believe that this system can be a solution. Is there anything else that you would like to share about what we've described that we haven't done yet?
Yeah, I mean, maybe on the big picture, I think we see here an impact of technology that since it is not focused on replacing or even enhancing the human factor, but it's focused on the target, then we should expect to see enterprises that are much more efficient. And once the enterprises are much more efficient, we as consumers will have that advantage of getting much better products at much lower cost, because the AI could make the right decisions to make the products much better and much cheaper in that sense.
Love it. Uri, thank you so much. That was a wonderful discussion. Great solution, great vision. Thank you for all this.
Thank you. It was a real pleasure to talk to you. Thank you.
And for you watching us, thank you for following us, and see you next time.